This captured German film is a technical report on the Fritz X radio-controlled dive bomb. The Fritz X was developed by the German Air Ministry at Peenemunde, Germany. Attempts were made at high angle and glide bombing. A combination of the two gives maximum control and maximum impact velocities. The high angle bombing is performed by aiming the aircraft. This releases the bomb in a 60-degree drop to right or left. The smaller 1,400-kilogram bomb is used for high angle work. The control systems of the two bombs are identical. This elaborate system of conveyor belts produced the desired airspeed of the dropping aircraft. The training device consisted of a bridge with a synthetic control system placed over the conveyor belt. Bombardiers were able to practice dropping the missile by use of the control stick in the right hand. The German Air Ministry realized training devices must receive operational equipment. Much equipment and time was spent in developing bombing techniques by synthetic training devices. In this synthetic training, it is assumed that the turn from the target of 60 degrees on either side has been made, and so will make flying a constant acceleration course to the target. The observer keeps the crosshairs of the bomb sight on the target by use of the control stick, usually situated to the right of the bomb sight. Only the last half of the flight of the bomb is given control because errors will then cause less deviation from the crosshairs. The arrow points at the bomb, represented by a white dot. The objective is to keep the dot hovering directly over the target. Wind tunnel tests of the Fritz X show the control speed of reaction with the control stick operated by the technician. A shortwave transmitter transmits the order from the mother aircraft to this bomb receiver. This view of the receiver shows its efficient fabrication. The installation is shock-mounted into the tail section of the bomb. The rear view of the bomb shows the stabilizing surfaces with the radio antenna pointed out by the technician. The roll gyro, which is installed in the rear of the bomb, prevents the bomb from rolling so that the signals maintain their orientation. The small roll gyro transmits electrical impulses to the doorbell light system of spoilers on the outboard system of the elevator. The technician rocks the missile, producing oscillation of the outboard spoilers to correct this condition. This oscillating system of control shows the engineering ingenuity of the Fritz X. With nothing more than a simple doorbell circuit, a full proportional control system is obtained. The spoilers reduce the velocity of air to the side from which they extend, therefore creating a force into the wing from the side the spoiler extends. The length of dwell of the spoiler in the extended position determines the rate of control. When no signals are given, the period of dwell of the spoiler on either side of the wing is equal. This frequency is above the natural response of the missile, therefore giving no control. Installation of flares in the rear of the bomb is a source of light, allowing the bombardiers to keep the light in coincidence with the target by the control mechanism. The flares operate in series. A Heinkel 111 was used as a test aircraft for practice dropping of the Fritz X. The Fritz X is attached to the airplane by means of a shackle. A motion picture camera records the flight of the bomb. Thus, the pilot and the bombardier can check and observe their proficiency. Equipment aboard the Heinkel 111 includes a shortwave radio transmitter. This antenna transmits the control signals to the Fritz X. The Heinkel 111 takes off for a bombing mission. The bombardier takes his position over the bomb site, adjacent to the control mechanism, and guides the missile to the target. The following animated sequences illustrate the aerodynamic features of the radio-controlled dive bomb. The objective of controlled bombing is the increasing in accuracy in hitting fixed targets as well as moving targets such as ships or railroads at long range. A practical and simple method of steering for the target is that method where the bombardier brings both bomb and target into line for some time prior to the impact. Position of the plane during release of the bomb. Position of the plane at impact. Adjustment period for target sighting. Controls. Release. Controls. Controls. Impact. Bomb release point. Position of the plane at impact. Natural bomb trajectory. Bomb release point. Position of plane at impact. Theoretical target sighting trajectory. Controlled bomb trajectory when target is sighted. Adjustment period for target sighting. Controlled dive bomb. Controlled glide bomb. Bomb released 2,000 meters sooner. Bomb release point. Position of plane at impact. Theoretical target sighting trajectory. Bomb release point. Position of plane at impact. Controlled bomb trajectory when target is sighted. Adjustment period after target trajectory has been reached. Controlled dive bomb. Controlled dive bomb. Total effectiveness in an upward direction. Effectiveness in downward direction, 1/2. Effectiveness 0. Effectiveness in upward direction, 1/2. Effectiveness in downward direction, 1/2.